Hi guys, today we're going to be looking at a question on forces. Question 2. A block, a mass of 8 kgs, is placed on a rough horizontal surface. The 8 kg block, which is connected to a 2 kg block by means of a light inextendable string, passing over a light frictionless pulley, starts sliding from point A as shown below, this being point A. Question 2.1. State Newton's second law in words. So this one's pretty simple, as it's a definition that you just learn it as it is and that's pretty much it. So the definition is that when a non-zero or a net force acts on an object, the object will accelerate in the direction of the force. And the acceleration is directly proportional to the force and inversely proportional to the mass of the object. When I say directly prop and inversely prop, it just means directly proportional and inversely proportional. Question 2.2. Draw a labeled free body diagram for the 8 kg block. So, free body diagram. So here's our 8 kg block. As we know, on all objects that are on a surface, it has gravity pulling it down. So we can say Fg. And then corresponding to that, we have a normal force pulling it up. So we can say normal force. As they say in the question, rough horizontal surface, so we know that there's friction. And since the object is moving in this direction, friction is in the opposite direction, therefore this way. And then obviously the tension of the pulley, which is holding the block, which is at a 15-degree angle. So we can just make it at a slight angle. And then this is friction. And then this is tension. Question 2.3. When the 8 kg block reaches point B, being here, the angle between the string and the horizontal is 15 degrees, and the acceleration on the system is 1.32 meters per second squared. Question 2.3.1. Give a reason why the system is not in equilibrium. So as we can see, they say that the acceleration is 1.32 meters per second squared. Therefore, the system is not in equilibrium as the acceleration is not zero. So that just means acceleration is not equal to zero. You can write that out in words. Question 2.3.2. Use the 2 kg mass to calculate the tension in the string. So this being the 2 kg mass. Using that, we can say, let's just write the question number, that F net is equal to M times A. And F net in this case, as we can look at the 2 kg block, we know that there's a force downwards being gravity, and then the tension upwards. So we can say that gravity, so mg, which would be of the 2 kg block, minus t is equal to m times a. And then we just fill in all our values, so m being 2, g being 9.8, negative t, mass being 2, and the acceleration being 1,32. When we work all of that out, we get t to be equal to 16,96 newtons. Question 2.3.3. Calculate the kinetic frictional force between the 8 kg block and the horizontal surface. I'm going to do this on the next page so that there's more space. So we want to calculate the frictional force between the 8 kg block and the horizontal surface, so the force that's acting in this direction. We therefore know that this force is opposing the tension force, but the tension in the horizontal component, because these are two horizontal components. Therefore, we can say that the tension force, obviously F net, is equal to M times A, and the F net would be the horizontal force of the tension, therefore T, and since it's the horizontal force, we say cos 15, as this is the angle, minus the friction force is equal to M times A. We know from the previous question that T is equal to 16,96, so we say 16,96 times cos 15, you can just put this in a bracket, minus F is equal to the 8 kgs, which is the mass of the block, times its acceleration, which they have given to us. When we calculate all of that, plug it into the calculator, you get friction to be equal to 5,82 newtons. And since it says calculate the kinetic friction force, we do need a direction, and it's going in this direction, so therefore to the left. Question 2.4. As the 8 kg block moves from B to C, the kinetic frictional force between the 8 kg block and the horizontal surface is not constant. Give a reason for this statement. The reason why the frictional force would not be constant is because the normal force will change. This is due to the angle between the block and the pulley changing, which could result in the block being lifted slightly. Therefore, it's no longer at the same angle of 15 degrees. So we can say that normal force changes. The horizontal surface on which the 8 kg block is moving is replaced by another horizontal surface made of a different material. Question 2.5. Will the kinetic frictional force calculated in question 2.3.3 above change? Choose from yes or no and give a reason for your answer. So, if the surface changes, obviously the kinetic frictional force has to change. This is because the frictional force depends on the nature of the surface, so how rough the surface is or how smooth it is. This is known as the coefficient of kinetic friction. So if the surface changes, the coefficient of kinetic friction would also change, therefore resulting in the total kinetic frictional force changing. So we say yes, because the coefficient of friction depends on the nature of the surface. And that's all for this question. Thank you.